I just stumbled upon this beautiful blog post from Jascha Sohl-Dickstein and thought of sharing it with you. What this blog post has done is has found a correlation between fractals and neural networks. If you are aware of what fractals are, then fractals are a mathematical concept where function is applied to its own outputs. Similarly, we do in our neural networks, and also fractals with fractals you can control the behavior with the help of some of the parameters, just like we do in the neural networks with hyperparameters. I will drop the link to this blog post in video description, but let me give you a very quick synopsis of what I have understood. But I would highly suggest that you read through this paper, and it's very finely and nicely written. Fractal patterns have been discovered here when plotting a grid search over neural network hyperparameters, and it suggests a fundamental link between mathematical fractals and machine learning dynamics. This discovery is huge in my humble opinion because it could lead to new approaches in tuning and understanding the quite complex landscape of neural network hyperparameters. Now, uh, if you have ever done a dense grid search over neural network hyperparameters, then you would see that some of it really looks fascinating. Let me play this video for you, for example. This is from his blog post, and I will drop the link to give the fair credit. So there you go. So it is a dense grid, and bluish color correspond to hyperparameters for which training converges, reddish color to the hyperparameter which training diverges. And the boundary between trainable and untrainable neural network hyperparameter configuration is fractal, and it looks really pretty. And so this is what the grid search over a different pair of hyperparameter, this time learning rate and the means of parameter in the initialization distribution. There are also similarities between the way in which many fractals are generated and the way in which we train neural network. Both involve repeatedly applying a function to its own output. In both cases, that function has hyperparameters that controls its behavior. Now, this website is full of nuggets. As you can see here, there are a lot of examples which are really good. For example, look at this with the activation function. So it shouldn't really be a surprise that hyperparameter landscapes are fractal. This is general phenomena. In these panes, we see fractal hyperparameters as I showed you above in these panes, where for every neural network configuration, it has deep linear networks. Okay, now there are a lot of other example here, and I will leave you with this. The best performing hyperparameters are typically at the edge of stability. So when you optimize neural network hyperparameters, you are basically contending with hyperparameter landscape that looks like this, as you can see on your screen maybe. Now some fractals, for instance those associated with the Mandelbrot and quadratic Julia sets, are computed by iterating a function and identifying the boundary between hyperparameters for which the resulting series diverges or remains bounded. Now, this boundary is fractal over more than 10 decades of scale in all tested configuration. And he has also produced this gem of a paper. It's just a 3-page paper which includes all of what I have just said and a lot more in in a better way, of course. So I would highly suggest that you should read it through, and I agree with this observation that fractals are beautiful and relaxing. That's it, guys. I hope that you enjoyed it. Hats off to Jascha Sohl for coming up with this amazing stuff. Thanks for watching. If you like the content, please consider subscribing to the channel. If you're already subscribed, then please consider sharing it with your network. Thanks for watching.